Hi everyone, welcome to Tech Initializer. Today we are diving into the absolute biggest event in the Java world this year, the release of Java 25. Now, why is this a big deal? Because it's an LTS, a long-term support release. This is a version that enterprises and big banks will use for the next decade. It's not just a small update. It's a complete overhaul of how we handle memory, how we write concurrency, and even how we start our applications. We are going to cover all 18 major features, showing you exactly what the code looked like before and how much better it is now. So let's get started. So let's start with the first thing a new developer sees, the main method. Previously, Java was often criticized for being too wordy. To print one line, you had to define a public class, then a public static void main method with a string arguments parameter that you rarely even used. It was a lot of ceremony just to get to the logic. The Java 25 improvement. This is now finalized. You can write a main method without a class declaration. Even better, Java 25 introduces a global IO class in java.lang package. Look at this. Instead of system.out.println, you can now just write void main io.println and your message. It's cleaner, it's faster for scripting, and it makes the language much more inviting for beginners. Next change is a massive quality of life change for developers. Previously, Java constructs had a golden rule. Super or this had to be the very first line. This was incredibly annoying if you needed to validate a parameter before passing it to the parent class. You would end up using a static helper methods just to get around the rule. So the Java 25 improvement is here. You can now write logic, checks, and calculations before calling super method. Notice here, we check if the value is positive before even we initialize the parent big integer class. This ensures our objects are always in a valid state from the moment of birth without messy workarounds. Next, let's talk about a part of your code that usually looks like a complete mess, the top of your source files. In previous versions of Java, even if you were using a modern modules, you still had to import every package one by one. You might think, hey, I will just use a wildcard like import java.util.star. But there was a catch. Wildcards only work for one single package level. They don't bring in sub-packages. So if you wanted streams and concurrent maps, you still had to import java.util.stream.star and import java.util.current.star. Most professional files ended up with a massive block of shame, 20 to 30 lines of imports before you even wrote your first line of logic. Java 25 introduces a massive cleanup tool called module import declarations. Instead of hunting down individual packages, you can now import an entire module in one single step. By writing import module java.base, you instantly get access to every public class in every package inside that module. That means lists, maps, streams, collectors, and HTTP clients are all available immediately with zero extra typing. It makes your code look incredibly modern and clean. Now you might be wondering, what if two modules have a class with the same name? This is a classic headache. For example, if you import module java. For example, if you import module java.base and module java.sql, both of them contain a class named date. If you just type date in your code, the compiler will get confused and throw an ambiguous reference error. The fix is simple and elegant. You don't have to get rid of your module imports. You simply add one specific line, import java.util.date. In Java's eyes, a specific import is more powerful than a module import. It acts as a tiebreaker. You're telling the compiler, I want everything from these modules, but when I say date, I specifically mean the one from java.util. It's the best of both the worlds, the massive convenience of modules, without the headache of name collisions. This is how Java 25 is finally ending the import wars at the top of your files. Pattern matching has been the star of recent Java versions, but it had a blind spot. Previously, you could use instance of on a string or a list, but if you had an integer inside an object, you had to manually cast it or box it into an integer object first. This was slow and clunky. The Java 25 improvement makes pattern matching now treats primitives as first-class citizens. You can now write if data instance of integer I directly. Java will check if the object is an integer and extract the value into I automatically. This unifies how we explore data, making our switch statements and if checks much more powerful and type safe. Now let's talk about threading. Before Java 21-25, threads were unstructured. They had no inherent relationship with the code that started them. Previously, using executor service or completable future was like fire and forget. If you started two tasks and one crashed, the other one would keep running forever in the background, wasting memory. This is called thread leaking. So in Java 25, structured concurrency treats a group of threads as a single unit. In Java 25, the API has been refined with the new structured task scope.open method, where structured task scope comes from java.util.concurrent package. When you use this within try with resources block, Java guarantees that all subtasks are either finished or cancelled before the code moves on. For example, in the code, if your fetch user fails, your fetch order is stopped immediately. It makes concurrent code as easy to read as sequential code. So how it works? The try with resources block ensures that even if you forget to cancel a task, the JVM will shut down all the subthreads before exiting the block. You can never have a leak. If fetch user throws an exception, the scope sends a cancellation signal to fetch order. If fetch order is currently waiting on a database or network, it receives an interrupted exception and stop immediately. The code looks sequential. You start tasks at the top, join them in the middle, and get results at the bottom. It follows the same logic as a simple if-else block. So this is the feature that finally kills the memory leak king, which is thread local. For decades, we used thread local to share data like user IDs or security tokens across methods without passing them as arguments. But thread local has three massive flaws. First is memory leaks. If you use a thread pool and forget to call .remove method, the data stays in memory forever. Thread local is mutable. Any method in your call stack can change the value, and the rest of your app will never know who changed it. It's heavy and doesn't scale well with millions of virtual threads. So Java 25 introduced scoped values. Think of a scoped value as a hidden parameter that is immutable and has a strict lifespan. It's safer, faster, and much easier to manage. Instead of setting a value, you bind it to a specific block of code. In the previous preview versions, the API was a bit loose. You could write or else null as a fallback, but in Java 25, that is officially banned. If you try to pass null to the or else method, Java will throw a null pointer exception immediately. Why? Because scoped values are meant for critical context. Java 25 forces you to handle missing data properly. You must provide a real, non-null default value like guest or anonymous. By removing the ability to use null as a lazy fallback, Java 25 forces you to write more robust, crash-proof code. It's modularity and safety working together to make your applications production ready. Now we often need lazy initialization, waiting to create a variable until it's needed. Previously, you would use a volatile field or a double-checked locking pattern. It was hard to get right, and the JVM couldn't optimize it because the value could technically change. So there is a Java 25 improvement called stable value. Think of this as a field that is final, but only after you set it the first time. You create it using stable_value.off method and then call or else set method. The first time it's called, it runs the logic load from disk. And every time after that, it returns the same result instantly. Because it's stable, the JVM optimizes it like a constant, giving you extreme performance. This is the most important feature you will never see. Previously, every single object you create in Java has a header, basically a hidden text of 128 bits of metadata. If you have a million small objects, half of your RAM is just metadata. So in Java 25, as a part of Project Lilliput, headers are now cut in half to 64 bits. The impact? This is massive. Without changing a single line of your code, your application's memory usage could drop by 10% to 20%. This means smaller cloud bills and more room for actual data. It's a huge win for high-scale microservices. Working with security certificates has always been a pain in Java. Previously, if you wanted to read a standard .pem file, you had to write custom regex to strip the headers or import a massive library like Bouncy Castle. So in Java 25, standard PEM support is now built in. You can use the new PEM decoder to directly turn those begin certificate strings into Java objects. This makes your security code cleaner, faster, and much more integrated with standard tools like OpenSSL. So how do you turn a user's password into a strong encryption key? Previously, Java lacked a unified API for this. Developers had to use specific secret key factories for different algorithms, which made the code hard to read and easy to mess up. So with Java 25 improvement, the KDF API is now available. Whether you are using PBKDF2 or HKDF, you use one consistent KDF class. This standardizes how we derive keys, making it much easier for developers to implement the best practice security out of the box. Finally, we tackle the slow startup reputation. Java normally needs time to warm up while the JIT compiler figure things out. Java 25 solves this with Project Leyden by separating the process into two steps. As you can see here, step 1 is creating the AOT cache. You run the application once in a training mode. The JVM watches your code, compiles the important parts, and creates a cache file like app.aot here. Step 2 is running with that cache. When you go to production, you simply point to that file. The JVM reads the cache and skips the warm-up entirely. The result? Your application starts instantly, ready to handle traffic from millisecond 1. Java Flight Recorder (JFR) is the best tool for seeing what's happening inside your JVM, and it just got 3 major upgrades. Adds CPU time profiling. Instead of just seeing how long a method took, you see exactly how much CPU muscle it used. Introduces cooperative sampling, making profiling even lower overhead, so it doesn't slow down your app while you're watching it. Add exact method timing. It gives you the precise duration of every call, not just a guess based on sampling. It's like going from a blurry photo to a 4K video of your app's performance. Garbage collection is all about trade-offs. Previously, the Shenandoah garbage collector was great for low pauses, but it treated all objects the same, which could be inefficient. So the Java 25 improvement is here. Generational Shenandoah is now a final feature. It applies the weak generational hypothesis, the idea that most objects die very young. By separating the heap into young and old generations, Shenandoah can clean up the garbage much more frequently without ever stopping your application. It's the ultimate choice for apps that need both high speed and low lag. Java 25 introduced advanced JFR profiling for CPU. You can measure real CPU cycles consumed by a thread rather than just walk clock time. You can use this Java command. Java 25 also offers cooperative sampling. JFR now only attempts to sample threads at safe points. This prevents JVM crashes or stop the world hangs that could occur when forcing samples on threads in unsafe states. To move forward, sometimes you have to leave things behind. Java 25 officially removes the 32-bit x86 port. If you're still running on a 32-bit hardware from 2005, it's time to upgrade. This allows the Java team to focus 100% on 64-bit performance for Intel AMD and ARM. The Vector API enters its 10th incubator phase. It's getting support for 16-bit floats and better off heap memory handling. So there you have it, the complete guide to Java 25. From compact headers that save you 20% on RAM to flexible constructors that make your code cleaner, this LTS release is a massive win for the ecosystem. If you learned something new today, please hit that like button and subscribe to Tech Initializer. Which feature are you most excited about? Let me know in the comments. Thanks for watching, and I will see you in the next one.